Okay, so let's say we have the usual particle that's forced to live between x equals 0 and x equals L, and that at t equals 0, the wave function is 1 over square root of 3, 2 over L square root, sine of pi x over L, plus square root of 2 over 3, 2 over L square root sine of 3 pi x over L. So t equals 0, that's the function. We can clearly see that this is a superposition of two eigenfunctions. This is psi1, the lowest energy eigenstate, and this is the second excited energy eigenstate function. So if we wanted to find psi of x and t, we would be doing 1 over square root of 3 times this first function times the time part, e to the minus I. We would choose n equals 1 because n equals 1 goes in here. Plus, same thing here, except there's a 3 here. So we attach a time-dependent part, which has an E3. So that would be the psi of x and t. And if we considered the probability of finding the particle as we did previously on one half of the well, let's say from L over 2 to L, that would be this object. We would have to integrate that. We can consider that. If we just think of this calculationally, it's clear that there's some time dependence here that's going to survive. So what would that look like? So this is L over 2 to L. We can also notice that these functions, we can, for simplicity, write this as 1 over square root of 3 psi 1x e to the I e1t over h bar, because we're constructing psi star, plus psi 3, right, that's what this is, of x, e to the I e3t over h bar, that's the psi star, times psi 1 of x e to the minus I e1t over h bar, plus 2 over 3 square root psi 3 of x e to the minus I, well, I can't really write it there, e to the minus I e3t over h bar. That's what goes there. So if we think of it as, and of course dx, so we're going to integrate something that involves psi 1, right, this term times this term. We get rid of the time dependence. The same is true of this term times this term. So we have a psi 1 squared and a psi 3 squared. Terms like, right, 1/3 psi 1 squared, then we have 2/3 psi 3 squared. Both of those functions are even, right, because we have an even function and we square it. Same thing is true here. What about the cross term? That's where the time dependence comes in. We have a cosine of omega t, where omega involves the energy difference between E3 and E1, divided by h bar. That's the frequency. And so it looks like a complicated calculation, but the point to notice is that psi 1 times psi 3, right, that cross term involves two functions of x that are also even. And so they can never prefer one side of the well over the other at any one time. So it must be true that this reduces to 0.5. The same is true for, obviously, from 0 to L over 2, because of the parity of the function. So we don't have to do the calculation. There's clearly time dependence there, but it's not a time dependence in the probability of finding it on 1/2 of the well.